Welcome to lecture 10 part 3 arithmetic circuit, half adder, full adder, subtractor. Discuss about how to design all of them. Half adder. Let me use the laser pointer. Half adder is a combinational circuit that performs the addition of 2 bits. This circuit needs 2 binary input and 2 binary output. So this is the typical circuit representation of half adder. So we have 2 input x and y, and we have 2 output sum and carry. So it can perform the addition of 2 bit actually. So that's why if we consider 2 bit as x and y, so this is our input and output side will be c is carry, s is sum. So if you add 0 and 0, sum is 0, carry is 0. 0 and 1, sum 1, carry 0. 1 0, sum 1, carry 0. 1 1, sum 0, carry 1. Okay, so for finding the equation for s, you need to do the KMF, right, for x, y, and s. So you'll find something like this: x prime y plus x y prime. For carry, similarly, you need to do the KMF for x, y, and c, and you'll find c equals x dot y. So by inspection, you can also get c or s as well. So like for c, so if you look at c, it says when input is same, actually when input, both of the input is high, output is high, otherwise output is low, which is basically the truth table for AND gate. So that's why you can see c equals x dot y. Similarly for s, for sum, we can say when both of the input is 0, output is 0, like both 0, output 0, otherwise output is 1, which is the truth table for XOR gate. So you can write x prime y plus xy prime, or x XOR y, something like that, right? So both is correct. So you can represent this way for equation 1. So the circuit representation will be like this, but for equation 2, circuit equation representation should be like this. So here we have x prime y. So this is our x prime and y. So both of them goes to one AND gate, and another is xy prime. So x and y prime. So both goes to another AND gate. And if you OR together, that means connect with OR gate, you will get the sum. And for carry x and y, so you take the x, take the y, so this will give you your carry. Same thing here, x and y OR gate, so x and y OR gate sum, and carry will be xy, so x and y AND gate, this will be carry. Full adder. Full adder is the combinational circuit that performs the addition of 3 bit, 2 significant bit, and previous carry bit. It consists of 3 input and 2 output. 2 inputs are the bit to be added, and the third input represents the carry from the previous position. The full adder is usually a component in a cascade of adders which add 8, 16, etc. binary numbers. So we have 3 input, 2 input and 1 carry from the previous bit, and the output is 2 output sum and carry. So if we have 0 0 0, then sum is 0, carry is 0. 0 0 1, so 0 1, sum is 1, carry is 0. So similarly 0 1 0, sum 1, carry 0. 0 1 1, so it becomes 1 1, so sum 1 1 0, carry 1. So this also becomes 1 0, sum 1, carry 0. This is again 1 plus 1, sum 0, carry 1. 1 plus 1, sum 0, carry 1. Here it becomes 1 1 1 3 1, that means 1 plus 1 10, 10 plus 1 11. So 11 1 and carry 1, so 1 and 1. So this is the truth table, right, for full adder. Similarly, you need to find the equations for sum and carry. For sum, you need to do the KMF, X and Y scene. So this is a 3 input K-map. So if you put the values from the truth table, so it will be something like that, and you can make a group. So there is no pair, actually they are individual group, 1 1 and 1. So if you solve it, you will find this kind of equation. Similarly for carry, you will get this kind of K-map. So here you will get 3 groups. So this is one group, another group, another group. So you'll get 3 product term. So this is your carry. So finally, this is your 4-letter sum and carry equation. So you can draw the schematic diagram from the sum and carry. So I'm not describing it because I think everybody can draw it by yourself. So you can write the sum and carry equation in this format as well. Same, C in XOR X XOR Y, and COT equals C in dot X XOR Y plus XY. So this is your assignment. So I think you can improve it. So the question says S equals, for full letter, so S equals this one. So you can convert in terms of this one, right? So similarly for carry, C equals this one. So you can finally find C equals this way. This is just use of Boolean knowledge, what you learn. Okay, and it will be helpful for designing full header using to half header. Full header using to half header. So we'll design full header which will have sum and carry using two half header. So this is one half header, this is another half header. So if you look at here this is X XOR Y and this is XY. So this is one half header and another half header X XOR Y, and this is obviously XY, another half header. Altogether we get this sum and carry. So full header sum we got X XOR Y XOR scene, X XOR Y dot scene plus XY. This is carry. So this is final product is a full header using these two half header. So that's what we got in the previous equations. So there is alternate representation of half header. So you can also check this one as well. Alternate representation of full header. This is the same concept. So you can check the concept as well. This is the equation how everything come. So you can also check the video from Nesca Academy. Now half substructure. For half substructure you have two input, two output, two input A and B, two output in D and B naught. Okay, so 0 minus 0. So your result is 0, borrow is 0. 0 minus 1. So 0 minus 1. So just look at here. So you can't really subtract 1 from 0. That's why I need to borrow from the previous bit. So if you borrow from this bit, so here you need to borrow 2, because 2 is the base for binary. Okay, so if you borrow 2 here, so write borrow 1 here. As you're taking borrow 2, so write 1. So 2 minus 1 is 1, and you borrowed 1, so borrowed 1 is 1 here. So B and D, so it becomes 1 1. So that's why your D is 1, D is 1, right? So 1 0. So 1 minus 0. So that means his result is 1. Your borrow is 0. 1 minus 1. 1 minus 1 is your borrow is 0. Result is 0. Okay, so if you find the equation for D and B naught, so your D becomes actually, if you look at the input, so it becomes high when becomes 0 when both of the input is same. This XOR, so A XOR B. And for B not, so it says when A prime, if you invert that one and do the multiplication, so it becomes A prime dot B, and this is the schematic diagram, right? So A XOR B, A prime B. I think you all can solve it by yourself or draw it by yourself. So this is the full substructure. So this is your assignment. So I'm giving you some hints. Okay. So for full substructure, you will have A, B, and C. So 3 input. C is your borrow from the previous bit. D is the difference. B naught is the output borrow. So 3 input, 2 output. So A, B, and C. D and D naught, difference and output borrow. So similarly, if you have 3, 0, so 0 minus 0 is 0, then again 0 minus 0 is 0. So your difference is 0, your borrow is 0. 0, 0, 1 for this one, 0 minus 0, 0, 0 minus 1. So 0 minus 1, your B is 1, your difference is 1, and your borrow is 1. So 1, 1. Again, 0 minus 1, so it will be 1. Again, 0 minus 1, then 1 minus 1. Right? So this is 0 minus 1, then again minus 1. So the output becomes 1, 0. So D is 1. So D is 1 and B is 0. Right? So if you look at here, so this is pretty much similar. So you cannot subtract 1 from 0. That's why you borrow 2. So then 2 minus 1 is 1 and borrow 1 is here. Again, if you want to subtract minus 1 from 1, 1. So 1 minus 1 is 0 and 1 comes here. So it says your borrow is 1 and difference is 0. So for 1, 0, 1 it becomes 0, 0, 1, 1, 0, 0, 0, 1, 1, 1 becomes 1, 1. So I think you understood that truth table. So now you need to find the equation, right? Say D and B naught. So you need to do the KMF for them and you can find the equation. And whenever you find the equation, you need to draw the schematic diagram. So that will be your full design for full substructure. So this is your assignment. I suggest you do it by yourself. So you have couple of more assignment. So it is in addition to full substructure, you need to do 4-bit parallel adder using full adder, BCD adder. So I have given you the link of the video. You can check it as well. You can check the textbook. There will be multiple solutions for all of them. So this video is about NESC Academy. You can check their video as well. They are very helpful as well. Okay, thank you. I think this part is clear to you now.